once again, I welcome you to this lectures room. Hope you are doing great out there. Good. We have a topic before me today called integration of trigonometric function. In mathematics, when we talk about trigonometric, we'll be talking about three major functions, which are the sine, the cosine, and the tangent. These three major functions, it is from it that other functions are derived from, such as cotangent, cosec, and secant. But on this topic, we'll be dealing majorly on sine, cosine, and tangent. We are going to as well add to it the cotangent function. Now, the sine integration, I'm going to take x as my variable here. Now, the integration of sine x will be equal to minus cos x plus c. Don't forget that to every integration, you must add your constant value. The c there is the constant value we are adding to it. Also, integration of cos x is equal to sine x plus c. Now, what is the correlation relevant between these integration values and that of the differentiation? Don't forget that the differentiation gives sine x to be cos x, while differentiation of cos x is minus sine x. And we all know that the integration is the anti-differentiation. That is, the value we are given as a question in differentiation are what we normally find as the answer in our integration. So that is a little bit related to one another, the value of the integration of sine x and that of cos x. Now, the tangent. Tan x integration or integration of tan x is given to be minus log of cos x plus c, negative value of log of cos x plus c. In other words, in differentiation, the differentiation of tan x is sec square x, which cannot be interchanged to one another to get log x. Now, how do we arrive there? But don't forget, in the differentiation of the reciprocal value of x, we always get logarithms values. Now, let us look at how we are able to arrive at the value we get for the tan x, integration of tan x here. Now, I take tan x will be equal to sine x over cos x. This is the value that translated to tan x. In our trigonometric, this is what we normally get for the value of tan x. It's workable. We can work it out. Now, the integral value of tan x, the x now, is going to be equivalent to integral value of sine x over cos x dx. It is from this information here we can get the value of the value for the integration of tan x. Now, in this case, I'm going to take this the denominator value here as a case, as what we are going to use to do the solution to my problem here. Now, I will now say let u equal to cos x. Any value anytime you want to integrate any forms of value that has to do with numerator and denominator, consider doing it this way. Now I go ahead. If u is equal to x cos x, in that regard, I'll have to differentiate this value here right now. I will say du dx will be equal to minus sine x. Take note of this. Don't forget, I have said it earlier, that the differentiation of cos x is minus sine x, which we have heard as well done when we are dealing with the integration of the differentiation of most of our expressions. Now, I will now make the head the subject of the formula. Why am I doing this? Why am I doing this? I'm doing it purposely because there's this value of the x here. I have to transform that value into a particular value that is going to be related to what I'm going to work towards. That is what you're supposed to also be looking at when you are dealing with this kind of a problem. Now I can now say the x, now making this the x a subject of the formula, the s will be equal to, if I look at this, I say this is over 1. By doing cross multiplication, I'm going to have the s multiplied by minus sine x, which the s will now be equal to the u over minus sine x. That is the value of the x. Let me underline this value here as well, because it's going to be useful very soon. Now, after I've been able to get the value of my x here, I will now come back here into what I am solving earlier. Now, I'm going to have this equation written back, which is sine x over cos x dx. This means we should integrate this expression. That is the meaning of what we just have here, which will as well be equal to sine x. Don't forget that we have represented this at the denominator value here by u. I'm going to put my u here now. And this dx has been gotten to be the u over sine x minus sine x. That will be multiplied by the u all over minus sine x. After I've gotten this, I am free to now cancel this sine x out of from this equation here. Don't forget, I'm still going to, no, I'm not going to have the x again because this is the value of the x. Now, this is what this equation means right now. Now, this one will now be able to be transformed into, after I've cancelled this out, that will be 1 over u multiplied by minus du, because there's a negative value here. Now, I'm having 1 over u multiplied by minus du. Now, I continue. So this as well can as well mean minus 1. Taking this negative value outside here, integral value of 1 over u du. That is what I am having right now. In the integration of a reciprocal of any value given to us, you should know that this value, the integration of this particular expression here means log u plus c. So this will now be equal to, right now, what I did to this level is the simplification of this expression. You can see that I'm still having this sign here. Now I want to start with my integration now. So I'm going to have minus 1 multiplied by 1 over u du. That's reciprocal of such a value is equal to log u bc plus c. Now this become minus log. Now what is the value of my u, which has been given to us before? Now cos x plus c with e. This is the value we get for the tangent, negative of log of cos x plus c. That is how it is derived. Now let's look at how we are going to find the value of cot x, that is cotangent stating. We want to deal with the integration of cotan x, taking x as the variable we are going to be using here. Now, don't forget that cot x is equal to 1 over tan x, that is reciprocal of tan x. That is the meaning of cot x. Now, don't forget as well that tan x is sine x over cos x, which means what we are having here is 1 divided by tan x. That is the meaning of this expression here, which is as well equal to 1 divided by sine x over cos x, which is as well now equal to 1 multiplied by, immediately you change the division to multiplication, this becomes cos x over sine x, which is as well now equal to cos x over sine x. In that regard now, I can now say that cot x is equal to cos x over sine x. Now, the integrating this expression here, cos x over sine x dx. Now, this expression here, which is called x, we are about to do the integration now. As we did when we are dealing with the integration of tan x, we can do the same thing here as well. We can now say that let u equal to sine x. Now, if u is equal to sine x, as we did when we are integrating tan x, we have to differentiate this u, right? The u, the x now. We're going to have the u, the x now will be equal to cos x. The u, the x is equal to cos x. Now, making the x the subject of the formula, the x will now be equal to du over cos x. After we have gotten the u, the x as the u over cos x, and we have the value of our u there already, we have to bring the value into this integral expression here. So we are going to have this information, which is cos x over sine x dx, will now be equal to the integral value of cos x over u. Don't forget that u has been taken to be the value that represents sine x multiplied by, now the value of my dx here now is the u over cos x. The u over cos x. I'm not going to have this one here any longer, because see what I'm doing there, I'm still doing the expression. Now, at this level here now, I can say that we can now cancel this cos x out from this expression here, which is going to leave behind the value for me to be equal to the integral value of 1 over u du. 1 over u du. We all know the meaning of this expression. That is the reciprocal of u here, which is going to become what? It's going to become the integration of this value now will be equal to log u is e plus c, which eventually will now become log what is the value of u? That is sine x plus c. That is the answer to the integration of cot x. We need to now look at some questions that are related to this set of integration of trigonometric function. Do stay tuned. This one here that asks us to integrate cos 2x dx. Now, integrating this expression, cos 2x dx. Now, have a look at it. We can see that it is not x that is this cos multiplied with, it is cos 2x. So in that regard, we have to transform this 2x into a particular expression. So let's represent it now by a particular value. Now I'm going to make use of u. I'll say let u equal to 2x. Then I can now say that the u dx is equal to 2. in that sense, what I am trying to do here, you can see that most times when I do the differentiation, while I am solving integration question, I want to make that value to be a value of the x. So I will now say the x is equal to the u over 2. The x is equal to the u over 2. So in this case now, I can now come here and say, this value, I'm going to bring it back here. This become cos. What is the value of 2x? U. What is the value of the x now? This is the value of the x. That is the u over 2. So in this regard now, I can now say that this value is as well equal to 1 over 2 because this 2 is at the denominator here. 1 over 2 multiplied by cos u du. You can see what cos u du 1 over 2 is still the same value here. So this one can as well now be transformed into 1 over 2 integral value of cos u du. Now, what this one is telling us is to integrate the cos u. And what is the value of integration of cos of a particular value? The integration of a cos value is sine u. That will become now equal to 1 over 2. I do not put this value there again because I've started with my integration now. Sine u plus c. So this will now become 1 over 2 sine. What is the value of my u? The value of my u is 2x. 2x plus c. That is the answer to that question. Let's have another one now. Another question here says that we should integrate 3x squared sine x cubed the x. That is 3x squared sine x cubed the x. I'm going to start with my integration now, which here now, what I will do here is that whenever you see a question of this nature like this in integration, one of the questions here must be differentiated. Now, looking at it very well, you can see that if one of them is differentiated, what we are trying to say is that that particular one that is differentiated, compare it to a particular information there or a particular expression there, is going to become the same value, which eventually will be able to cancel one another out. That is our intention here. Now, which one am I going to try to differentiate here now? If I differentiate this, I'm going to have 6x. What if I differentiate s cubed? If I differentiate s cubed, I will have 3s whole, 3s squared. It's related to one another, so I have to differentiate this. So I will now say let u equal to s cubed. The u, the x, will be equal to 3x squared. Now, having got it this way, you can now say that, well, the x now, as I've been doing so far, what we always do is to make the x subject of the formula. The x will be equal to the u over 3x squared. Now, this value is here. I have this value. I underline it too. Now, I'm going to insert the value back into this expression here, which I'm going to have this expression now becoming 3x squared, which is already there, sine, what is the value of my x cube? My x cube has been represented by u now. U, what is the value of the x now? That is the u over 3x squared. Now, from this set of expression now, I can cancel this 3x squared here now, because one is at the numerator, the other is at the denominator, and all the values are multiplied with one another. In this case now, I can now say that this expression has become sine u, the u, that's the value we are having that is left behind now. So I will now try to integrate this expression that we have now. Integrating sine u. Don't forget that The integration of sine u is minus cos u plus c. That is the integration of sine u itself. But what we are asked to do in the question given to us, it is the x value that is there. So we have to change this u to that x expression. So what is the value of u here? That will be equal to what? Minus is now equal to minus cos what are u? S cubed plus c. That is the final answer to this question. This answer we have here now, we've been able to solve the value of 3x squared sine x cubed dx. Do subscribe to our channel for you to be able to have access to all our lecture. Thanks and God bless.